E-waste, the environmental challenge of electronic waste. Improper disposal of electronic waste, e-waste, which includes discarded electronic devices like smartphones, computers, televisions, and appliances, poses significant environmental risks. As technology rapidly evolves, more devices are rendered obsolete, contributing to the growing e-waste problem. When these devices are not disposed of properly, they can cause serious harm to the environment. Environmental harm from improper disposal of e-waste. Toxic chemicals and heavy metals. Many electronic devices contain hazardous materials like lead, mercury, cadmium, and brominated flame retardants. When improperly disposed of in landfills or through incineration, these toxic chemicals can leach into the soil and groundwater or be released into the air. Lead, for example, can contaminate water supplies and cause neurological damage to humans and wildlife. Mercury, often found in old batteries and screens, can bioaccumulate in fish, making its way up the food chain and posing risks to both ecosystems and human health. Air pollution. Burning e-waste, a common practice in some developing countries, releases toxic fumes into the atmosphere. These fumes contain harmful substances like dioxins and furans, which are linked to respiratory problems, cancer, and other health issues. The improper incineration of e-waste also contributes to global air pollution and climate change, as the process releases greenhouse gases and other pollutants. Soil and water contamination. When e-waste is dumped in landfills, hazardous substances can seep into the surrounding soil, rendering it infertile and unfit for agriculture. The contamination of soil by heavy metals and chemicals can also affect plant and animal life. Furthermore, rainwater can wash these pollutants into nearby rivers and lakes, contaminating water sources and harming aquatic ecosystems. Resource waste. E-waste contains valuable materials like gold, silver, copper, and rare earth elements, which are often not recovered when devices are discarded. Mining new materials to manufacture electronics is resource-intensive and causes further environmental degradation, such as deforestation and habitat destruction. The failure to recycle e-waste leads to the unnecessary depletion of these finite resources. How e-waste recycling can help. Reducing pollution. Recycling e-waste can prevent toxic substances from being released into the environment. Through proper recycling methods, hazardous materials can be safely extracted, treated, and disposed of, reducing the risk of air, soil, and water contamination. This also protects communities, particularly in regions where improper e-waste disposal is common, from the harmful health effects associated with exposure to these toxins. Conserving resources. Recycling allows for the recovery of valuable metals and materials from old devices, reducing the need for new raw materials. By extracting reusable components like gold, copper, and rare earth elements, recycling helps decrease the environmental impact of mining and reduces energy consumption associated with the production of new electronics. This conserves finite resources and lowers the carbon footprint of the electronics industry. Reducing e-waste volume. As recycling programs become more efficient, the volume of e-waste entering landfills can be significantly reduced. By properly processing obsolete electronics, fewer devices are discarded improperly, reducing the strain on landfills and minimizing the environmental hazards they pose. Energy conservation. Recycling e-waste requires less energy than producing new products from raw materials. For example, recycling metals like aluminum and copper from e-waste uses a fraction of the energy needed to mine and refine these materials. This energy savings contributes to reduced greenhouse gas emissions, helping to mitigate climate change. Job creation and economic growth. The growth of the e-waste recycling industry can stimulate economic development and create jobs in collection, processing, and technology recovery. By investing in recycling infrastructure, both developed and developing countries can turn the e-waste problem into an opportunity for sustainable growth while also addressing environmental concerns. Circular economy and sustainable practices. Embracing e-waste recycling aligns with the principles of a circular economy, where materials are reused, refurbished, and recycled instead of being discarded. This approach promotes sustainability by extending the life cycle of electronic products and minimizing waste. Companies can design products for easier recycling, repair, or upgrades, which can significantly reduce e-waste generation. Consumer awareness and responsibility. Raising awareness among consumers about the impacts of e-waste and the importance of responsible disposal is vital. Educational campaigns can inform the public about recycling options, proper disposal methods, and the benefits of buying refurbished or eco-friendly electronics. By making informed choices, consumers can contribute to reducing e-waste and support sustainable practices. Legislation and policy frameworks. Governments play a critical role in addressing the e-waste challenge. Implementing stringent regulations on e-waste disposal, promoting recycling initiatives, and providing incentives for manufacturers to adopt sustainable practices can drive significant changes. Extended Producer Responsibility (EPR) laws can hold manufacturers accountable for the life cycle of their products, encouraging them to design for recyclability and take back old devices. Conclusion. Improper disposal of electronic waste has significant environmental consequences, from the release of toxic chemicals and air pollution to the contamination of soil and water. However, by embracing e-waste recycling, we can reduce pollution, conserve valuable resources, and help mitigate the negative environmental effects of the growing e-waste crisis.